Good morning, everyone. It is my privilege to introduce Dr. R. Rakesh Kumar, sir. Now, let me share a brief overview of his remarkable career and achievements. Dr. R. Rakesh Kumar is an associate professor in the Department of Physics at NIT Warangal. He completed his PhD from the Indian Institute of Science, IIS, Bangalore, where his research focused on the growth of semiconductor and semiconducting oxide nanowires by vacuum evaporation methods. He also holds an MSc in physics with a specialization in electronics and instrumentation and a BSc from Usmania University. Dr. R. Rakesh Kumar research focus on energy harvesting technologies like piezoelectric and triboelectric nanogenerators, as well as 2D materials, green hydrogen, IoT sensors, and self-powered devices. He has published 92 journal articles, 9 conference papers, and 8 book chapters, earning over 1,248 citations and a H index of 21. He also reviews articles for top journals such as ACS, Elsewhere, and Springer, so on, etc. In his career, Dr. Rakesh Kumar has held teaching and research positions, including as an assistant professor at Geetham University and NIT Warangal, where he was later promoted to associate professor. He has also been a visiting faculty at IISER Bhopal. He has guided multiple PhD and MSc students, with 3 PhD theses completed and 3 more ongoing. Dr. Rakesh Kumar has worked on prestigious projects funded by organizations like DST, ECR, and industry sponsors. Some of his notable projects includes a 50 lakh projects on Kelvin probe machine development and a 28.97 lakh project on flexible nano generators. His achievements includes clearing GATE with 90.6 percentile and receiving awards like the Teaching Excellence Award from NIT Warangal and the Best Award at the IUMRS ICY RAM 2016 conference. Dr. R. Rakesh Kumar is an active member of the Materials Research Society of India and the Indian Science Congress Association. His recent works focuses on advanced topics like sustainable energy harvesting, triboelectric sensors, and nano generator technologies, providing innovative solutions to challenges in energy and material science. His Google Scholar and ORCID profiles highlights his extensive contribution to research and academics. With this, I would like to welcome Dr. R. Rakesh Kumar, sir, to deliver his lecture. Thank you.
We are glad to have Professor Rakesh. He is my colleague, friend, and also fellow researcher. So very happy to see your growth, Professor Rakesh. Thanks for accepting to act as a resource person in our GAN program. And I would like to invite Professor Pankaj also on the stage to give a memento to Professor Rakesh as a token of gratitude.
So today I'll be talking about energy harvesting using nano generators, as well as you're going to see some self-powered sensing applications. Okay, you must be curious by this time what is this LEDs are glowing, how these LED lights are glowing here. Are you curious or not? So it's a simple hand tapping, right? You are not producing anything, right? It's just a simple hand tapping, it's producing electrical energy from it, right? Yeah. So as you can see here, this is the simplest thing one can think of it about the nano generator. This is a small device. You can see it can fit in the palm. It is able to light up 4 LED lamps. You can see here about 100 LEDs are glowing with a simple mechanical energy harvesting. So what I am going to do here is I am going to convert mechanical energy into electrical energy by a means of a technology. So that technology you are going to see today, how the technology has been evolved and what are the physics principles behind it. If you want to develop such technologies, what are the things you must know it. All those things will be covered in this talk. So this is the outline of the presentation. So I'm going to start with what is the need for energy harvesting, like why do you want to go for the energy harvesting. Then we see the why you need a small scale energy harvesting, because my work will be mostly focused on small scale energy harvesting with triboelectric nano generator. Then I'm going to talk about what are the fundamentals which are required to understand to make a device. Then what are the materials we can use for triboelectric nano generators, and what are the possible application you can make out of triboelectric nano generator. This is the outline of presentation. So let's start with basic human needs. These are the basic human needs. One, everybody wants it, like security, safety, whatever you want. So you need anything else? This much is enough for us. This much is enough for us. You need anything more than this? Say yes or no at least. You need something more than this. What was that extra component? You need a Wi-Fi and battery. Your day start with Wi-Fi only, right? Your day start with battery, whether mobile is a battery or not. Agree, right? Everybody. Maybe if you go back to 20 years, this may not be the equation, because nobody bothered about battery charging, because Nokia mobile phone stands for 2-3 days. Okay. Nowadays that's not the case. Your smartphone you will discharge in a daytime. Not even daytime. If you start using Wi-Fi, it will be discharged very fast. So the idea is now the generation has upgraded to an extent that you have to depend on energy. There is no other way. You cannot survive without energy. It can be a small scale energy. It can be a bigger scale energy. You need some kind of energy source. This is where my research is focused here. So you consider two kind of energy systems. One is the larger scale, which is utilized for agriculture and industries, and there is a small scale. This you may be interested, okay? Because everybody is using a wearable technologies, everybody using a portable sensors, trackers, GPS trackers, all those things. All those run with a small battery, okay? So for small battery, if the battery get drained, you need to replace the battery. Agree, everybody? You have to replace the battery, including this mobile pointers, this laser pointers as a battery. If this get discharged, you have to throw the batteries out. Maybe if you take your digital watch, whatever you have, you are having a batteries, okay? You are going to throwing them out. As a result, it's going to pollute the environment, okay? Especially this kind of waste comes from the batteries, going to pollute the environment. So we want to make a technology which will generate the energy from the environment, so that these devices run on their own. They need not to be charged again and again. They need not to be replace the batteries again and again. If you go to large scale energy, we will be having hydrothermal, hydroelectric, nuclear, thermal, all those energy sources are available, which are there for quite long time. But this percentage around 59% from coal. But as time passes on, as you move further and further, maybe by 2040 or 2050, you are going to end up with most of the fossil fuel get exhausted. You need to find an alternate source. At the earliest possible, of course, we have predicted in advance that we need to improve our renewable energy sources to make our end needs, to make our life more dependent on the renewable energy sources than fossil fuel, because it's going to exhaust of some time. It won't stay for longer period. Okay. So as a result, we started exploring what are the other options for us. Like you have a solar panels, you have a wind energy, you have a tidal energy. Of course, the tidal energy still need to be explored to make it more efficient. These two are already established technologies. Solar panels were there for last 40 years. We are trying to improve the efficiency, because this technology is almost stabilized. Like we are able to produce, sell it at a normal price at a local shop also nowadays. You can buy solar panels in a local shop also. So that's the technology we have developed. Maybe small efforts are still going on to make it more efficient solar panel. That is the only thing we are going in. So at this place, if you want to replace this all the fossil fuel, you need to just improve this more number of wind tunnels or more number of solar panels. And at the same time, you need to think about how to recycle the solar panels after their end life is done. After 15 years or after 20 years, you need to think about those possible problems. Okay. So we are happy with the large scale energy harvesting because we are able to produce good amount of renewable energy. So there is no issue at this place. So advantages, as I said, it's freely available, like if you consider sunlight and wind, and environmental friendly. There is no emission from carbon monoxide, carbon dioxide, and easily recyclable. Of course, this is not that easily if you consider solar panels because it needs very precise recycling process. Okay. So this is our NIT Warangal main building, which is completely powered with solar panels. Now come to the why you need to have a small scale energy harvesting. As I said, one is you wanted to power your portable electronic devices, that is already there. If you want to think even more practical way, more serious way, this is a possibility. This is a place where you need small scale energy harvesting very badly, very needs. If you consider these implantable medical devices, especially if you take a pacemaker which makes heartbeat proper in number, okay. All these implantable medical devices are insulin pumps. All these are implanted into your body, which runs on the battery. Okay. Suppose if you take a case of a simple pacemaker has a battery inside. If you are going to insert into the human body, and this will give electrical pulses to the heartbeat whenever it goes to a minimum level. Okay. So after some time, this gets drained up. This battery gets drained up. Then what you are supposed to do? You have to make another surgery, take that out, replace the battery, and put it back. The person like you and me, it is kind of okay because we are young to have to go to second surgery. But if you consider a person who has more than 55 or more than 60 and all, they will be having other issues, maybe blood pressure issues or sugar issues. They may not, that's not easy case to go for a second surgery. It may be a risk for the patient also. So, but if at all, if you harvest some energy by some device which can power this device automatically from the human body, then you don't need to replace the batteries at all. The battery will be recharged by the human motions and it will run for indefinite time. The only thing is you have to do only one surgery, which will just implant your medical device. So this is a place where you require small scale energy very much. And also if you consider this kind of bridges, okay, suppose you put one sensor here which is battery powered, suppose the sensor stops sending the signals, or maybe it may be railway track condition, whether the track is proper or not. Now the battery is gone, someone has to go here and change the battery. It's too risky. You cannot go every time and change the battery. Okay. So if you can make use of this vibration energy from these tracks, if you can convert, if you make one device here which can power those sensor indefinite time, then you don't need to replace the batteries at all. So this is what I am trying to do in my research work. So this is where your small scale energy comes into picture and make an impact on our lives. So to do that, we have several nano generators. Why we call these nano generators? We are going to generate a small amount of energy. That's why we call them as a nano generator. Sometimes people use nanomaterials in making these devices. We call them nano generators. The first one is a pyroelectric and second one is a thermoelectric. These two are based on the heat to electrical energy. Wherever there is a waste heat energy, we can convert them into electrical energy by the normal Seebeck effect in this case. In this case, orientation of the dipoles with respect to the temperature change. This is not my interest because this is very uneven conditions because you need to maintain the temperature difference accurately. It's not always possible, but whereas my interest is here, piezoelectric and triboelectric nanogenerator. Here, these two devices will convert mechanical energy into electrical energy. Any type of mechanical energy. The advantage with the mechanical energy is you have mechanical energy everywhere. You're walking, running, jogging, worst case your heartbeat also mechanical energy. Your blood stream flowing through veins also a mechanical energy. So there are a lot of mechanical energy sources available around us which are freely available, which are going waste. We wanted to harvest those mechanical energy to make the electrical energy. So these are the two effects. One is the piezoelectric effect, other one is the triboelectric effect. This is done by Professor Jidal Wang from Georgia Tech. in 2006 and 2012 respectively, both the technologies. As I said, you have mechanical energy everywhere, right? Infrastructure, transport, industry, environment, you have everywhere mechanical energy available. Only thing is you need to make a device which can take that mechanical energy and produce the electrical energy. So let's start with the simplest case. Piezoelectric, this you must have studied in your school level and your college level, where there are certain kind of materials, typically non-centrosymmetric crystals, okay, where centers of positive and negative charges are not coinciding with each other. So those materials, if you apply a pressure, something like this, so the center of positive and negative charge will not coincide. As a result, you are going to have a potential difference across the two surfaces. Okay, so that piezoelectric effect, taking any mechanical energy which is applied on the substrate from the top side and going to produce the electrical output. So this is one, but the disadvantage with the method is you do have a limitation on the material choices. You cannot use whatever the material you wanted to choose. You have to choose a material which will satisfy the non-centrosymmetric crystal. So typically like zinc oxide, PZT, barium titanate quartz. These are very limited material choices. So if you want to improve something or if you want to develop something, you do not have many material library. We have to play along with this only material. So as a result, this is kind of area of research which is not progressing very fast, but still people are making efforts to make a more sensitive piezoelectric nano generators. Now come to the triboelectric nanogenerators. So triboelectric nanogenerators, if you want to understand, before that you need to understand what is meant by static electricity. Hope you must have encountered this in a lifetime, at least once in lifetime. When you touch a door handle, you must have got the shock, especially metal handles like copper or stainless steel handles, because typically in winter time there will be a lot of static charge deposit on these metal surfaces. When you touch them, there will be a conducting path. As a result, you are going to get a sudden shock. Okay, and similarly, if you consider other case, your lightning also comes from the static electricity, which is decorate on the clouds of clouds. And the static electricity is not good for your CMOS ICs or your integrated circuits. Okay, so basically what I'm trying to tell is the static electricity is not a good thing for us, but triboelectric nanogenerator going to make this unwanted effect into useful effect for us. We are going to make this unwanted static electricity effect into useful product to make energy harvesting. You can see here this is a Van der Graaf generator where electrons are passing from this generator to this human body. Since both are electrons which are charged on the air, both get repelled each other. As a result, your air get flipped off exactly like this. Okay. So this is the effect what we are going to use in triboelectric nanogenerators. So you can see here the first phenomenon in triboelectric nanogenerator is the contact electrification. It is everywhere, it is available everywhere. When you rub two materials based on their electron affinities, one metal get positive charge, one metal get negative charge. That's what happens when you rub a balloon with a air, or when you take a charged object to another charged object. You can see here now scale is rubbed, it is charged with some charge. Now you can see it is giving a pushing force to the paper. So this is the contact electrification where two material comes under a contact, and because their electron affinities or because of the difference in their work function, they exchange the charge carrier. That means one will be giving the electron, one will be accepting the electron. As a result, one become positively charged, one become negatively charged. So this is the first principle we are going to use in triboelectric nanogenerator. And second one is the induction phenomena, electrostatic induction. Induction means when there is already charged object, if you bring charged object close to another object which is not uniformly distributed. You can see this is a charged object. Moment you keep it here, you can see the charges are getting redistributed. As a result, you are going to see some free electron which can flow across the electrodes if you connect some electrodes to that. So these are the two phenomena we are going to use. One is the contact electrification. You require two material to be contact each other, and there if you when they separate up, there will be induction phenomena. Okay. So these are the two principles on which we are going to make our triboelectric nanogenerators. This part we have discussed just now. Now let's start with what are the components of the triboelectric nanogenerator. As I said, if you want to make a triboelectric nanogenerator, you need two layers. One is positive triboelectric layer, other one is a negative triboelectric layer. It is, you can name it other way around. Typically you need two arbitrary layers, one supposed to give electron, one supposed to accept the electrons. What we do is we attach those two materials to two electrodes, and this entire setup will be placed on an acrylic board. It is a non-conducting surface and this also going to place an acrylic board, and we are going to place it one over each other with some small sponge spacer, like you can see here. This yellow color is one triboelectric layer or one positive layer, and this white one is another triboelectric layer. And if you put this upper one to the down one, there will be a sponge across the four corners. You will be having a finite gap between the two friction layers. Hope this is clear for everyone. Is it clear, everyone? Because if you clear only, later slides will be understood, otherwise it will be confusing. Okay, so what we are going to have is, we are going to have two frictional layers with a spacing between them, and if you apply the mechanical force from top side, something like if you apply from the mechanical force, this layer will come and touch with this layer. When you remove the force, they will get separated automatically. You don't need to separate them with a manual thing, because this sponge elasticity will make them separated out. So in a two-dimensional way, you can see something like you have two frictional layers with two electrodes contact with each other. Now you are going to connect your measuring device here to measure either current or voltage, whatever you wanted to measure it. Hope this is clear for everyone, this slide. Yes. Now how do you select the materials? So as I said, you need two materials. We have a triboelectric series here. This is standard series. It's still this upgrading. Here what we do is, we we put them the materials according to their electron affinities. So if you look at this green color table, these are the material which has more positiveness. That more positive metal means they are ready to give electrons as much as. Okay. So this material has the most electron donating capability compared to this last one. Similarly, in this case, this last one, this silicone rubber has more electron accepting nature. They take as many as electrons they want, and this has a lesser electron affinity to take the electron. So if you choose this extreme end material and this extreme end material, you are going to have more potential difference, because this is going to give more electrons, this is going to take more electrons when they touch each other. Okay. So you have to choose these materials such a way that you should have maximum electron affinity difference. In a simplest case, you can consider the maximum work function difference. Okay. So this is only list prepared by the standard materials. We have n number of materials. You can choose any material here, because at the end of the day you need two materials which has a two different electron affinities. That's the thing. You have a good amount of choice to select any arbitrary material. We are going to see all the materials also in today's lecture. Now what is the working mechanism? So this you have to stay focused and stay attention. You can see here, this is the starting condition. When the two layers are separated from each other, there is no potential difference, there is no current in the circuit. When they touch each other, one is giving the electrons becoming positive, one is taking the electron becoming negative. Now contact electrification has been taken place. After you apply the force from here, this layer touched here, and you have a contact electrification between the two layers now. Okay. Now when they start separate, when you remove the force, they start separated because there is a sponge spacer here. This sponge spacer push them up. When the layers separate up, there is a potential difference. Okay. To this potential difference drives the electrons from bottom electrode to the top electrode, so that this potential difference get nullified. So you are going to make it stable condition or equilibrium condition. So if your electrons travel from here, there will be induced positive charge here, there will be negative charges here, this will get neutralized. That means it's like a equilibrium condition. So during this time, you are going to get one current pulse in the circuit. After it gets equilibrium state, when you are going to apply once again force on this device, they are coming closer together again. When they come closer together, the potential difference will decrease. Now whatever the electrons which are flowed in the previous case, they will again travel back to the previous electrode. In that case, you are going to get another small current pulse in the circuit. As you can see in the animation here, animation is not playing, I guess. Let me play once again. You can check out the animation once again. Yeah. So now there is no charge. Now contact electrification is taking place. One is positive, one is negative. When they are separating up, you can see electrons are flowing, and there is a positive charge, there is a negative charge. Now first peak is generated. When it is coming down, the electron will flow back. You are going to see the negative peak in the. So at the end of the day, if you keep on tapping the device, you are going to have alternating current or alternating voltage in the circuit. That current and voltage utilized for powering the LED lamps or LEDs, what you have seen in the first slide. You have seen, right? Some hand is tapping the device. So this electricity produced by the device is powering those LED lights and LED lamps. So this is the working principle of your triboelectric nanogenerator. This is one mode of operation. This is called vertical contact separation mode. We do have other modes like lateral sliding, where your two friction layers will move like this. Instead of like this, they will move like this. Or and sometimes you can also have a rotational thing where two layers will be rotating like this. And the last one is the single electrode mode. This is most useful thing. These two are the most useful modes for the TNG. This for mechanical energy harvesting, this is for the sensing application, where this material can be even hand also. Hand also can act as a material to touch the electrode to get the contact electrification. So these are the modes of your triboelectric nanogenerator where you can design your nanogenerator. So this is what happens when you bring two materials closer. There will be electron cloud overlap on each other. So when they come closer and closer, the electron jumps from this cloud to this cloud. When they separate out, the electron cannot jump back, so they will get separated out. As a result, one become positive, which has given the electron, and other one become negative, which has took the electron. Now what are the parameters which affect the TNG output? As till this point we are clear. If you want to make a triboelectric nanogenerator, you need two frictional layers of two different electron affinities which are attached to two electrodes, which will be connected to a wire which measure the current or voltage, and you have to repeatedly apply the mechanical force to make them contact and separated. Okay. Now what are the parameters? As I said, first one is the work function difference, or you can say electron affinity difference. The more the difference, the better will be the electron transfer, you are going to get the better output. And surface contact point, even though if the potential difference is more, if the contact points are not more, this surface has only 10 contact points, you get only 10 electrons get transferred. If there are 100 contact points, 100 electrons will transfer. If there are 1000 contact points, 1000 electrons get transferred. So more the contact point, more the charge generation will happen, and how much surface charge density it can hold, how many induced electrons can hold it back. Then you are going to have dielectric constant, which is nothing but again storage of the charge. Dielectric is nothing but again. So these are the material properties which need to be taken care before you make the device. And coming to the device parameters, so you can have other different parameters like what are the force you are applying on the device, whether you are applying a 5 Newton force or 6 Newton force, that is the first thing. And the second thing is the frequency of the applied force, how fast you are applying or how slowly you are applying the force. And the spacing between the friction layers, whether it's too spaced or only very closely spaced, and what is the testing environment, whether you are testing this device under normal conditions or humidity conditions or temperature conditions. So all those things will affect TNG output. Now what are the devices we use for making this device characterization? Once your device is fabricated, you need to measure the current, you need to measure the voltage, you need to measure the charge, you need to measure the work function, you may need to measure the dielectric constant. Okay. So these are the instruments. You can use oscilloscope for measuring the voltage, and current amplifier measuring the current, or you can use any source meter from Keithley you can use to measure current, volt, and this is the electrometer which can measure both current, voltage and charge. And this is a Kelvin probe microscope which is used for measuring the work function of the material, whether the material has more work function, less work function, and this is the AFM to measure the roughness of the material. So this information will give you how many contact points can take place when two materials are attached to each other. And there is LCR meter which will measure the dielectric constant of your triboelectric materials, and there is electrostatic voltmeter which will measure the surface potential of your triboelectric layer. So these are the instruments which are required to characterize your triboelectric nanogenerator. Now we'll go to the fundamental physics. So if you want to understand the fundamental, you have to go back to the Maxwell's equation. So if you look at this Maxwell equation, this is for electromagnetic induction, rate of change of magnetic field produce the electric field. And there is Ampere's Maxwell's law. This is where our triboelectric nanogenerators comes into picture. If you look at the Ampere's law, this is what Ampere's law states. When current passing through a metal conductor, you will be having a magnetic field around it. And thus we call it the del cross B equals mu 0 times J. This is valid for some time. And then after that Maxwell's came into picture and said that this equation is not valid. If you consider the capacitor case, if you consider parallel capacitor case, so when you charge the capacitor, there will be a conduction, there will be a current passing between the two capacitor plates, that we call them as the displacement current. That is happening because of time dependent electric field, dou E by dou T. When the capacitor is getting charged, you are going to have rate of change of electric field between the plates, that will produce the current in the magnetic field. So as a result, so till this it was there, this extra term was added because when you have a capacitor case, you have to consider this term. Now after this, there is one more correction happened for this equation. That is where our nanogenerators comes into picture. So this is the actual Ampere's law. Then Maxwell added this term, Now nano generator is going to add one more term for the equation. What is that? In both the cases, either it's a piezoelectric or triboelectric nano generator, what you are doing is you are separating the positive charges, separating the negative charges. It's nothing but a polarization. Polarization means having the same kind of polar things, like either completely positive or completely negative. If you consider both the cases, you can see you are separating the negative charges here and positive charges here, similarly here also. So you are doing something like a polarization. That is nothing but dou PS by dou T. Rate of change of polarization with respect to time it is happening. So because of this rate of change of polarization, you are going to see current in the external device. This extra term should be added to the Ampere's Maxwell's equation. So if you rewrite the equations, you are going to have something like this, where your displacement current will be dou E by dou T. This comes from the capacitor, and dou PS by dou T comes from the nano generator. So this is the physics you need to understand if you want to understand about triboelectric nano generators properly. If you want to compare electromagnetic triboelectric, it's as simple as, in case of electromagnetic, you do not have any material choices. I mean, like, you have to use only iron core with what are the standard metal, whereas in triboelectric, you can use as you want, whichever the material you wanted to use, provided as long as they are not same materials. Okay, and this works at higher frequency. Your triboelectric nanogenerator works at the lower frequencies. Like we can work this nanogenerator at 1 Hz, 2 Hz also, but this will work at typical higher frequencies. You don't produce, the more the change of magnetic field with respect to time, you are going to get more current with the electromagnetic generator. Okay. Now come to the material choice. Now what are the materials we can use? What are the materials can be explored to make this kind of device? You can see here there are n number of materials already explored in the literature, right from oxide materials, metals, semiconductors, porous material like metal organic framework, dielectric materials. Some of them used waste materials, some of them used polymers, some of them used high temperature oxides, some of them used 2D layers like graphene, carbon nanotubes, or MXenes and all. Okay, I'm going to show you a few of the results which we done at our laboratory. We'll start with the zinc oxide. So in this work, we have synthesized zinc oxide nanosheets and aluminum by simple hydrothermal method, where your plain aluminum is coated with zinc oxide nanosheets. You can see these are the zinc oxide nanosheets and aluminum substrate. Now we made a device keeping zinc oxide nanosheets as one frictional layer and opposite as a PDMS as other frictional layers. So when you tap this device, we could able to produce, we could able to produce around 1000 volts and 150 micrograms current. In TNG you get huge amount of voltage, but it's only pulse voltage, it is not a DC voltage. So it stays for a few milliseconds, it won't take much time to get back to zero. And we have done a load characteristic for the device where we varied the load resistance and measured the TNG output voltage and found that at 10 megohms it is giving the optimum response or optimum power, which is around 10.8 watt per meter square. This device we used for powering the electronic devices. Typically in case of this thing, we are powering this digital watch here. You can see in the video. It's not playing, I guess. Let me play fast. You can see now, this is a TNG device. This TNG is tapped by the hand and there is a full wave rectifier here and there is a capacitor. The capacitor getting charged. After capacitor get charged to certain level like 1.5 volts or 1.2 volts and your digital watch gets on. As long as this tapping is there, your watch will run without any battery. This is what we were trying to do. So now this is self-powered. If you put this TNG device, if there is a mechanical energy source, that mechanical energy source will tapping the device and your digital watch will be running continuously without any break. So this becomes a self-powered system. Okay. So this even calculator also we will be able to run. So we just made it little, because it takes some 1 to 2 minutes to charge the capacitor to desired level. Now you can see your calculator is running without a battery. So this is the first application we have explored, powering the small portable electron devices. Later we want to use same device for powering the pacemaker or powering the insulin pump. So based on the power requirement, we need to do some additional modification in the energy management circuit. Now we explored later MXenes, which is a 2D materials, where we have take max phase materials of, we have many libraries for max phase. So out of which we have taken titanium aluminum carbide. So we mixed with silicon solution and we made a composite film. As you can see here, this silicon mixed with magazine sheets of titanium carbide, and we made a composite film. This is a device geometry. When we tapped this device with the hand tapping, we could able to produce around 370 volts without magazine, and with magazine we are going to produce 600 volts. And power density without adding magazine to the silicon, we are getting around 5 watt. When you add magazine, we are getting 15 watt per meter square. Typically these magazines are negative in nature. They have triboelectric negative nature, and your silicon material also triboelectric negative material. When you add one negative material to the other negative material, its negativity will improve a little ahead. So as a result, you are going to see improved performance from 5 watt per meter square to 15 watt per meter square. This we used for different application I am going to show you, and later we explored double layer hydroxide with the magazine sheets. Even we have improved further to almost 35 watt per meter square, and we have explored this for lighting the LED lamps, as you can see here. So with the simple hand tapping, so 2 LED lamps are able to glow. And this security application we have made it. So in this case what we have done is we have utilized our TNG in the single electrode mode, where your hand acts as one friction layer and your magazine silicon acts as another friction layer, and we connected output of the TNG to a Arduino board with a blink cap. Okay. Whenever someone touches the magazine surface, you are going to get electrical pulse. That pulse will be read by the Arduino board, will send an SMS that someone has touched my door handle. Suppose you attach this TNG device to a bureau or maybe a locker. If someone trying to open, you are going to place it here. Whenever someone touches, then there is a triboelectric effect, there will be electric pulse. That pulse will activate this Arduino board to send SMS to your mobile user. Okay. We have implemented it. I am going to show the video now. You can see here. So we are touching with hand, we are attached to a small woven. This is a woven door. You can see woven door is adding a triboelectric layer here. Now blink cap will give you a message that some unauthorized access has been taken place. Okay. And if you open the message, you can get the information about when the access was done, at what time, how many attempts has been done. Everything can be done with the Blink Cloud app. It takes few seconds, so you can see now it is received. Now you can see its time, everything is detected, and date, everything will be done by the Arduino boards. This is with hands. Suppose someone cleverly uses a gloves, but still gloves also triboelectric material. Still you get the alert to the user. So it doesn't matter whether you use a hand or gloves or anything, until unless you use a paper. Paper is electrically neutral some extent. Okay. Otherwise, most of the cases you will get the alert. So this is a more secure system than anything else. So this is a touch sensing for security applications. Later we explored metal organic framework. This is a class of materials where you have a lot of porous structures, okay, where you have a metal, ion and organic linkers. With this you get different kind of morphologies which will be useful for us. And in addition to that, we are going to have functionalization. This is the extra thing we have metal organic frameworks will be having, where you can functionalize the metal with electron donating groups or electron accepting groups. If you want to improve the negative property, you can attach the electron accepting group like fluorine, chlorine. Okay, if you want to donate the electron, you can also use NO2, NH3, like that you can use it. So previously the MOFs are used only for catalysis, magnetism, other things, but we have used it for the energy harvesting application with a new field. First we start with a GIF67. This is Geolite Immutable Framework. This number comes from the university, sometimes comes from the place, sometimes comes from the scientist name. Where we have done is we have synthesized the MOF by simple hydrothermal method, then we mix with some PVA polymer solution, then we made a composite film, then we made the TNG device with GIF67 as a active friction layer. So this is producing around 70 milliwatt per meter square. The power density is quite small which compared to other reports, but it depends on the material property that need to be improved. And we use for powering energy harvesting tiles. If you look at this application here, so we have kept 4 devices here and someone is stepping on it. You can see almost like 600 LEDs are glowing for a single footstep. So you can make set of tiles here, make in a footpath, you can make energy harvesting tiles. And similarly, you can also see here this LEDs which are organized in a typical pattern. If someone presses them, you are going to get these LEDs are on and off. This will be used for indicators. Suppose in a building, if you want to put a, yes please. Yeah, it depends upon the mechanical strength of your material. Suppose your metal is brittle, then you may not use higher force. But typically we don't apply excess force because we are interested in biomechanical energy, like what human can apply the force.
Minimum force requirement.
No minimum force. Even if you want to use for sensing application, even if small touch also enough. Touch also, you need to apply forcefully also. Ideally you need to just make a small contact, that's all. If the contact force is more, you are going to get more contact area. You may get little increased signal, nothing else. Because if you look at the outputs here, if you go back and look at the output here, you are getting 100 volts peak, right? If you touch it, you may get 15 volts peak. That is more than enough for the Arduino board to read and send the signal. And we are done with MYF 303 metal organic frameworks, where we directly synthesize metal organic frameworks on MYF 303 here, which is a plain aluminum, and this is MYF 30 coat aluminum, and this is a device geometry, where FEP acts as a opposite layer and MYF 30 acts as another opposite layer. And we could able to get power density of around 7.8 watt per meter square, and we confirmed that this particular metal is tribo-positive material, because most of the materials are not known their tribolicity, because only we have a standard series of material. Other material need to be confirmed whether it is a tribo-positive or tribo-negative. So with this work we have confirmed that this metal is a tribo-positive material. And we used it for powering 4 LED lamps here. Well, this video is not playing, I will just play it quickly. So now we improved so that we could able to power up 4 LED lamps, you can see now. And we also used for cell power indicator. This is an interesting application developed in our laboratory. What we have done is we have put TNG devices near the footrest, where you are going to change the gear, apply the brake. And we have put 2 more at the near the handle, at this place near the handle. So when you take a turn left or right, this TNG get pressed and you are going to get the automatic indication. You do not have any battery to tell that I am taking a turn. Moment your handle is slightly left or slightly left, immediately the light which is at the back side, suppose in this case you are taking a left turn, you can say left light LED, this lamp is on. In this case right turn, this LED is on. Or else if you want to, let's say, take a left turn, right turn, you want to give an advanced indication, you can always press this TNG device 3-4 times with a leg. It will give an indication that I am taking left or right. So I have a video, I will show you now. You can check out this real-time video that we have recorded in our department. So you can see this is the TNG at the footrest, and these are the 2 LED lamps which are connected through the wires, and this is another TNG here, this place. If someone tap on this device 3-4 times whenever you want to take a left turn or right turn based on his interest, you can see now he is tapping the device here, and you can see there is a clear indication. So this technology will completely remove the, completely overcome the issues with the indicator problems. We don't need any battery right now. So if you put this technology into all the motorbikes and all, people can use this without any battery system. Even if the battery is not there for the bike, still you can give the indication whether you are taking left turn or right turn. So this enhances the safety for the vehicles, or avoid the road accidents and all. Yes, please. Yes, handle will give the indication, but that will give you only once. If you are taking only, it will press only once, means you will get only one thing. But if you have a, if you tap the near the leg, it will be more easy. You can give multiple indication that I am taking and all. If someone is not very attentive, this may not be a good idea, but this will be a good idea. You can tap 3-4 times, people can see that they are taking left or right turn. Okay. And later we started using the waste materials for nano generators, where we have explored some medical waste, as you can see here. We start with simple saline bottle. As you know, most of the time these saline bottles all get wasted, sometimes burn outside the hospital. Okay, what we have done is we take a small piece of saline bottle. This is nothing but a small plastic piece, and we made one as a saline bottle as one frictional layer, opposite as a silicone layer, and we could able to achieve 8.7 watt per meter square, where we have used for powering LEDs as well as sleep monitoring and touch sensing. I'm going to show you the videos in a moment. And this is a small piece which cut from the saline bottle 5x5. And this is a device geometry, and this is the output you are getting from the TNG. And you can see the stability is almost 3 months also it is stable. After 3 months also we test the device, still you are getting the stable output from the TNG device. So in this case we have explored a new application for sleep monitoring. So this looks very silly, but actually it's a serious issue. People who doesn't get sleep in the night sometimes. they get sleep maybe 10 to 11, maybe 11 to 3 o'clock, they may not able to sleep. They will be just simply rolling on the bed or left, right, moving up and down. Okay, so this is a serious issue. Okay, so how do you monitor that? You have to put some sensor in the bed and to monitor it. That is the only way you can do it. So what we have done is we have implanted our TNG device in the pillow. And okay, so the person who is in the photograph is myself. I am the one who has done this experiment. Okay, so this TNG is implanted. 2 electrodes are taken. I connect to the oscilloscope. When the person is sleeping peacefully on the pillow without any deviation, the oscilloscope will show the stable DC value, 0 volts, whatever it is. Moment there is a disturbance, whether you're moving left or right, upside down, all those things, there will be a disturbance. As you can see, there is a disturbance here, there is a disturbance here, there is a disturbance, there is a big disturbance because I completely flipped upside down. Okay. So same thing here. So if you record the entire night and next day morning if you look at that peak pattern, you will understand that at what time you have a sleeping issue. You may not have time to go and see your watch what time it is and all every time. Okay. So this is a good example of triboelectric nanogenerator for sensing application, as you can see in this video. So this is now peaceful sleep, no spikes in the oscilloscope. Moment I start moving left or right, you can see a small spike here immediately. Very fast. The response will be, because you're getting a lot of high voltage pulses, even small disturbance also will give a pulse in the oscilloscope. If I change drastically, completely upside down and all, you're going to have more. So now you can see the peak is more distinguished. Okay. So if you record this signal, you can monitor the sleep of a person, how peacefully he has slept in the last night. And we'll go to the touch sensing application where we have used single electrode mode. This is a simple touch sensing application. As you can see here, it's a single finger touch. You can see there is a nice output pulsar coming out. This with one finger. If you add 2 fingers, it will be little multiplied. You can see the output magnitude is changed. If I go with the 3 fingers, it will be even bit more. Now it is bit more. So this is used for touch sensing as well as the force sensing also. If 1 finger there is a little lesser force, 2 fingers little more force, 3 fingers will be even more force. So you can use for touch sensing as well as force sensing application. And we also use the X-ray sheets. Nowadays it is almost digital now, but still some places still people use X-ray sheets. We can also use X-ray sheets. And this other works where we have done printer cartridge. If you look at this Canon LBP 2900 model cartridge, so this most of them will throw away. Once if you will refill it 3-4 times, if it doesn't work properly, we will throw them away, that entire thing. But if you open carefully, there is a OPC drum which is in blue color, which is a charge storing layer actually in printer, where ink is attached, ink particles will be attached to here and going to print on the paper. This actually aluminum tube which is coated with some polymer layer. What we have done, we have taken this tube and made it a flat sheet, and we made a device out of it, and we could able to produce 4.6 watt per meter square with this electronic waste. And same with seashells, we collected some seashells from the near seashore in Vijayawada, and we made a powder out of it, and we made a device out of it, and it's also produced good amount of voltage and current. And we have used for respiratory monitoring. Suppose you want to analyze a breath pattern, how the breath pattern is taking place. We have implanted TNG device here near the chest. As he breathes, you are going to see pulses in the oscilloscope. Yeah. Sorry, video got stuck. Okay, fine. It got stuck. Sorry. Yeah. Now we move to nanofibers, where we have done simple nanofibers into the electrospinning machine, where we have done GIP67 with some PVA solution, and finally we made a nanofiber mat with the electrospinning machine. So this experiment we are going to demonstrate in the afternoon lab, where you are going to see electrospinning machine, how fibers are made out of electrospinning machine. So after that nanofibers are made, we have sorry, it went very fast. Yeah. Oh, so fast. Yeah. So these are the nanofibers which we synthesize without GIP67. This is with GIP67. These bubbles are where GIP69 is embedded into the nanofiber, and we got around 11 watt per meter square as a power density for this particular nanofiber mat. And we use this for smart hygiene system. So most of the time, this washroom, especially maybe railways or in public places or hotels and all, So someone has to go and check whether what is the condition of the bathroom, whether it is cleaned or not, or how many times it has been used. We have to monitor it manually. So instead of doing that, what we have done is we attach a small door sensor, which is nothing but a triboelectric sensor here. Whenever the door open and closes, there will be one electric pulse coming to the Arduino board. So this Arduino board, which is powered with a small battery here, this Arduino board will send signal to the mobile user whenever door close and open by 10 times or 20 times based on the user. Someone who uses bathroom, one count will be counted in the Arduino board. Whenever it reaches the count, maybe 10 or 20 count, it will send a SMS to the user that washroom has been used enough number of times, it times to clean the washroom. Okay. So as a result, you don't need to monitor the washroom every time. So it automatically sends whenever the required number of usages are done by the users. This is another explored with a simple thing. Probably I'll show the video, you can see here. So this is one triboelectric layer and this is another triboelectric layer which are connected with a small electrode and all. So the small wire which is coming to your Arduino board, which take the electric pulse coming out of your triboelectric nano generator. Now we are going to close and open the door 10 times or 20 times based on how you program your Arduino board. Now you can see it is counting the number. Moment it reaches 10, it will send a SMS to the mobile. Mobile automatically receives mobile SMS from the Arduino board, which has inbuilt Wi-Fi module, which connect through. Now when 10 reaches, he will give, now SMS is received that washroom has been used 10 times. Now it's time for cleaning. So this one, another application we have used it. And we have further explored PASPER based TNG. Professor Arnath must have told about many PASPER material in the last lecture, I guess. Fluorescence, luminescence, afterglow PASPER, all those things. So we took some material from his laboratory, which is vanadium pentoxide, zinc vanadate. So this we have used as one of the friction layers. We could able to generate a power around 7 watt per meter square, and we are also able to power on one electroluminescence device with this. And further we also take another PASPER, which is a tritium based European doped tritium, which used for UV light sensing. In presence of UV light, what is the output of the TNG, and in the absence of UV light, what is the output of the TNG. We can clearly see that there is a distinct intensity in the in presence of UV light, without presence of UV light. So this we can use for a UV light sensing application. And this we have explored for smart parking application, where what we have done is, so typically if you go to any shopping mall or any public place where there may be many parking slots, but you don't know which parking slot is free, first thing, whether parking slots are available or not also we don't know. So to overcome that problem, what we have done is, for example, we have taken 4 parking slots here, and under this 4 parking slot we have put our TNG devices. Whenever car parks into the slot, this TNG get compressed and give a signal to the Arduino board. Arduino board will give you a display that this particular slot is occupied. Okay. So similarly, whenever you take out the car, they get separated out, then that will give an indication that that particular parking slot is vacant. So this way we can display like this. If you look at here, there are 2 parks are parked and 2 are outside. Now you can see there are 2 red, 2 green. That means 2 red are occupied and 2 green are free to occupy. So this is a kind of visual indication at the outside the shopping mall or near the parking slot, where user can see which parking slot is free, which parking slot is not free. You can see in the demonstration here. So this is a TNG device. You can see the sponge spaces, everything. And such 4 devices are placed here, 1, 2, 3, 4, and you are going to cover with a small cardboard. Now this is the Arduino board, which is take the signal from these 4 TNG devices, which is programmed with a small Python code. And this is a display where you are going to have your display, which parking slot is free, which parking slot is occupied. As you can see here, I can see here whenever the first car comes, you can see this is in, this parking slot is filled. Now 4th one is filled, then 2nd one is filled, then again you can see here now all 4 are filled now. Moment if you take out the car, then the particular slot becomes free. Now this is free, and 4th one is free, then other one will be free as long as you remove the car. So this is a kind of indication to the user that this particular slot is free. Then further we have used some gel-based materials from chemistry department. Professor Nagarajan sir has provided some supramolecular gels. We have used this making a humidity sensing application where we have used for measuring the humidity in the environment. We have tested our device under different humidity conditions like 70% humidity, 80% humidity, and we could clearly see the device able to sense the humidity levels and producing the different output voltages depending on the humidity levels. Whenever you want to measure humidity, you can use this TNG device for humidity sensing application. And this is the most interesting and potential application from our end. We have used this TNG for hydrogen generation. Now everybody knows hydrogen technologies. People are investing crores of money to produce hydrogen-based cars. Because when you run hydrogen, when you run a car with hydrogen, you are going to end up byproduct as water. So it is a pollution free. That's what people are focusing hydrogen. So what we have done is we have used this I think Pankaj sir must have covered electrocatalysis just few years, right? You need some power source to activate this electrocatalysis. The power comes from our triboelectric nano. As simple as this setup will be same. We are not going to change the setup. I'm going to change the power source. Instead of giving from a power source, I'm going to give a TNG, and these two friction layers get contact in each other. Then the current will be produced. The current will be given to this system. And the electrocatalysis will take place here, and one place you are going to get hydrogen gas, in other case you are going to get the oxygen gas. As you can see in this screenshot, from 0 minute the water level is here. As the time progresses, you can see water level is coming down. That means hydrogen gas is generating and going up. Probably I'll show the video. Video is available here. Yeah, you can see here. Can you see bubbles are going up? Small bubbles. And this water droplet level will come down as time passes on. This is the level of the water. You can see it will come down. So this the output will be generated by your any mechanical motor to run it. In later application we have done self-powered electrode deposition. So if you want to coat this key with a copper, so you take a copper sulfate solution in the copper as an electrode, and you are going to get TNG output as energy for this electrode deposition. We don't give any battery here. The energy comes from the TNG device, which is tapped by a machine here. Instead of hand tapping, you are using a machine here. The energy will come through here through a rectifier and applied to this electrode system, and electrode deposition will take place, and your key will be coated with copper. So electrode deposition of copper will be taking place on the. So we had run it for around 10 minutes of tapping. But this just only show the potential of this technology. You should not tap with the machine ideally. You should tap with some available mechanical source. You should not provide any mechanical source by some power. So we run around 10 minutes. Probably this video will go ahead, little ahead. Still low. It's playing. It will be stopped in a couple of seconds. Done. Another one more minute. Now you can see the key from that solution. It will be coated with copper nicely. Can you see all of you? Yeah. So this is a self-powered electrode deposition with the triboelectric nano generators. This we have demonstrated in our laboratory. And later these nano generators were used for chemical sensing, where you can send some chemical into the environment while it is tapping. When these gases go and absorb on the surface one of the triboelectric layers, their electronic structure will change. Suppose if you are operating at room temperature and normal ambient temperature and ambient air and all, it has some output voltage. Moment you send some external gas, maybe ammonia or carbon monoxide, the gas molecule will go and stay on the surface of these triboelectric layers and change its work function, maybe electronic structure or electronic properties. As a result, you are going to see different output voltage. As you can see here, this particular chemical is changing its concentration right from 0 to 80 micromoles. You can see the output initially is coming around 275, then it start decreasing with respect to the concentration is increasing. So this can be used as a chemical sensing. So this is also same thing, as you can see with respect to different ppms of different ammonia gas, this TNG output is getting changed. You can also see the sensitivity. A tribo is not sensitive to all the gases. It is, in this case, this particular TNG is sensitive to only ammonia gas. Other gases is giving a very limited response. So you can clearly say that whenever ammonia is there, your TNG can be used as an efficient sensing element. And this is the work which was done by other researchers. Whatever you have seen is done in our laboratory at Department of Physics, NIT Warangal. Here we have done this all works from Jadal Bank from Georgia Tech, where he has made a triboelectric nano generator with a flag shape. Whenever this flag flips left and right with respect to the wind energy, these friction layers get contact each other, going to produce electrical energy. Or this rotation also, these are the two friction layers. Whenever air will rotate this upper arm, this lower arm will be rotating, and these friction layers get attached to each other and rotating each other. As a result, you are going to produce. Or sometimes you can put your nano generator to the leaves, maybe for a plant and all. So whenever these leaves flicker, whenever the air passage is there, you are going to produce output. Well, I will show the video here. You can see now there is a nano generator attached to these leaves. Now whenever the air is passing by, you are going to have output out of it. Now you can see some small LEDs are glowing outside. So you can connect LEDs to TNG device, and TNG device is here. Whenever there is a contact electrification, your LEDs are glowing. So we can use for wind energy harvesting. You can see more clearly here. This is the friction layer here, and you can see LEDs are glowing whenever the airflow is taking place. You can also use for tidal energy. This is more potential, where you are having a small friction layer. The circular one is the one friction layer, and the inner surface is another friction layer. If you put this center structure in a water medium, water waves will go up and down. This inner spherical ball will move up and down based on the wave energy, and there will be a contact electrification that we are going to harvest it for the energy generation, as you can see in this video. Now this is a TNG implanted inside. Now you can see it is able to power these LEDs. So if you have such 3-4 things, suppose if you have something like this. I'm sorry. It's not playing or what? Yeah. You can see here now a group of TNG devices, not one. The energy which comes from here, you can see powering so many LEDs, which is free of source. You don't need to have anything. Just put some devices in the water. Wherever there are water waves, it will harvest the energy and produce it. And we can also use for rainwater. If rain droplet falls on the triboelectric surface also, you are going to get the electrical output out of it. This is a liquid based TNG. You can see these are the friction layers. Now water is spraying here through the spray nozzle. Whenever the water falls on these surfaces and drop down, there will be contact electrification which continuously light up. Since the water droplets are coming a short period of time and going away, you are going to have continuous lighting here. We can also use for force sensor, touch sensor, as I said just now. So this for health monitoring application. So as you can see, he made a TNG device in this small wristband, which is a small TNG device here. Whenever your pulse, there is a pulse, right? The small pulse will be there. So when the pulse go up and down, the small pressure is enough to produce a current signal which can be monitored for pulse sensing, whether person has pulse or not. This sleep monitoring, which we have already explained. And this is the last application, implantable medical. This is the place where we are interested actually. Whatever we have seen is all the auxiliary application what we have with TNG. So what we have done, what they have done in this case is they have attached TNG device to the diaphragm of the heart. When the diaphragm beats, like when heart beats, the diaphragm go up and down. So that mechanical energy will be converted as a signal. As you can see here, this is the TNG output and this is the ECG output, that what we typically do in a hospital. Both are look similar. Like if you have a TNG implanted to your device, it will give a signal to see what is heartbeat. At the same time, it will give the energy that can be stored in a energy management circuit and can be power the pacemaker. That's the idea. So initial trials were done on this. Initial trials were done on the pork, and they could able to generate certain signals and able to monitor also, but still this is under trial stage. It takes years to make a actual device to make a completely implantable and self-powered medical devices. So whatever we discuss only limited. We have huge number of applications, right from self-powered system to blue energy to micro machining, and you have hybrid cell, you have a solar cells with triboelectric nano generator, super capacitor with nano generator. There are many other hybrid energy harvesting systems, so we can explore still more. So till this part we have seen only the positive side of the nano generator. Now we are going to see the negative side of the nano generators. These are the problems and future perspectives which is limiting us not to explore much. If you look at here, the first one is the AC output of the TNG. As I already told in the first slide, you are going to get the oscillating output, but most of your electronic devices does not run on AC, they will run on the 5 volt DC power supply. So we need to have some energy management circuit, or you need to have a certain kind of a design for TNG which would produce a stable DC output. If you get that, it's a magic. Then you can run almost every device with the TNG. You don't need any battery at all. So this is a potential problem which is stopping us to go ahead further. If you can make this challenge fast, rest will be easy. Low current output of the TNG, this need to be improved. This is not a problem. This is our control, because the current will be decided by how many charges are getting transferred. You can kindly modify it, but first one is a typical problem. And the last one is the growth on conducting substrates. So whatever we have seen, that I said there is one electrode on which you are going to put the friction layers. How do you put it? You cannot just attach with a simple tape. You cannot do that. Okay. So if you are able to grow on the substrate, that will have a more mechanical adhesion, because you are going to tap this device several number of times. If it is not grown directly on the substrate, it will just get out of that substrate. It will go off from the substrate. You are going to end up with no output. So if you can make the system or make the deposition or growth on the conducting substrate directly, it will be easy for make the electrical connection, as well as the mechanical stability of the film also very good. And we need to go for the large area. You cannot run 5x5 device for practical application. Suppose if you want to make a energy harvesting tile, you need at least 20 centimeter by 20 centimeter, 30 centimeter, 30 centimeter device. So you need to go for the large scale thing. And this is the problem, long-term stability. Since you are applying a mechanical force on the device, how long your frictional layers are stable. Okay. Suppose you have zinc oxide coating. Your zinc oxide coating may not withstand after maybe 1 lakh cycles or 2 lakh cycles, then your device will not work. You need to look for a friction layer which can withstand large number of test cycles, like say 10 lakh cycles or maybe 20 lakh cycles. If that is the case, then your device long-term stability will be good. And this power management circuit should be done by electrical people to make more efficient way to take all the energy generated by the TNG. So these are the challenges. People who want to work on it, you can work on the first problem, AC output to DC output, and you can also do the strategies to improve the current output, or to find out different techniques to make films on the conducting substrate. And this is the work what I presented is not my alone work. It is group of people who has done or contributed. So these three from physics department, and this from EC department, this from chemistry department, we together as a group, and this is my research team. People who has the work which I presented is from these research scholars work. Okay. And this is today's lab session. You will be showing electrospinning process for preparation of nanofibers and metal argon framework by electrode deposition, and TNG powering LED lamps and touch sensor will be demonstrated in the afternoon lab session. And I thank you very much, and I thank you both the organizers, Venkatesh as well as Vamshi Krishna sir, for providing this platform. If you have any clarification, please feel free to ask. We have, I think, another 15 to 20 minutes time. You are free to ask any kind of question. You make some energy management circuit which takes TNG output, make a stable DC output. Okay, then the future is TNG. It is everywhere, it will come. Wherever you want to run any portable sensor, portable device, which suppose you want to monitor a weather condition, maybe you want to measure the temperature outside, you made a temperature sensor which is battery powered. Remove that, keep some triboelectric device which has some mechanical energy source, maybe wind energy or something, it will run automatically. It takes time because initial hard disk, like if you If you look at in that context, when the solar cell were fabricated way back, maybe 30 years back, the efficiency was only 4%. Okay, it was only 4%. Nobody thought that solar cell will come as a commercial product. Now we are getting around 28% efficiency. So it takes time. Maybe someday it may take years also. But there is a scope. At least, if not the powering the electron device, worst case you can use as a best sensor, which doesn't require any power. Suppose you take the touch sensor, doesn't require any power. You need only one triboelectric surface, which is more active to the human touch. Okay. Anything else?
Shown many prototypes of
Yes. Yes, sir. Those videos are recorded in my laboratory.
implemented in the market.
No commercial product is developed out of it. Few of them we patented it. A few designs were patented it, and few were. See, if you want to commercialize it, you have to compete with the existing products. Okay. See, I cannot sell the touch sensor product because there are already commercial available touch sensors. And there are issues, as I said, right? If I use this device for longer period, let's say 1 year, 2 years, if your film is prone to moisture, okay, if the moisture sensitive, your film may not produce the same response as day 1 and 365 days later. Okay, there are such issues. You should make a device which will stand for a longer period, larger number of test cycles. Suppose if it withstand, let's say 10 lakh cycles without any degradation in the output signal and without any degradation in the material property, then you can commercialize it. The problem here is, the moment you want to commercialize, the first thing they'll ask is what is the lifetime of your device. So that is where most of the problems will come. Not only this device, if you make any device in any either battery or supercapacitor, whatever you make it, at the end of the first question will start from what is your device lifetime? How long your device will work? You may be saying that my supercapacitor is showing 970,000 and all, but the next question is how many cycles it will stay that capacity? Okay. No, at this moment I do not have any plans because we stuck with several problems. So until we answer them, we cannot go for commercialization. We can only patent it for the time being. This is our idea that nobody can copy it. That's the only thing we can do it now. Anything else? That's all? So I'm closing down, everyone. Okay, then thank you all for your kind attention.